In this video, we're going to explore how to graph linear functions and what the basic shapes of these graphs of linear functions are going to look like. So first, in order to find what the basic shape of a linear equation is, or one of this form y equals x plus 2, the first thing we want to do is just go back to plotting some points and then look for our pattern and then ask ourselves the question, well, what would happen if we did this an infinite number of times? So first we're going to evaluate all these different x values, and if you remember, to evaluate, keyword here being evaluate, means that we're going to plug in these values and then simplify. So the first thing I'm going to do is evaluate y equals x plus 2 for this negative 2. Or in other words, I'm really asking us to do y equals, instead of x, I'm going to evaluate by plugging in the negative 2 plus 2. And since negative plus 2 is 0, we find that y equals 0. Now going back to our graph, what this means then is that I now have a point at the ordered pair. Remember, ordered pair means x, y. I have an ordered pair negative 2, 0. This is telling me to go to the left 2 and up and down 0. Or in other words, I'm going to have a point right here on our graph. So now I'm going to keep going. So next thing I'm going to do is plug in negative 1 for x. So this would be y equals, instead of x, negative 1 plus 2, which gives us a positive value of y equals 1. So this now gives us the ordered pair negative 1, 1, which I can plot. Remember, negative 1 for x means left 1, positive 1 means up 1. So continuing this pattern, I plug in 0. I get y equals 0 instead of x, plus 2, and 0 plus 2 gives me 2 for my y value. So this xy pair, x is 0, means I'm going to go left to right, none. Y being 2 means I'm going to go up 2 on the y-axis. And here's my next point. And you might be able to start seeing a pattern emerge. Let's just finish off our table. Next, I'm going to plug in x is 1, and I find that 1 plus 2 is the value 3 for y. So the ordered pair 1, 3 is literally telling me for x to go right 1, the 3 to go up 3, getting me my next point. So then one more quick point here. I can plug in 2 for x, or in other words, y equals 2 plus 2, giving me 4. So I have the ordered pair 2, 4. This tells me to then go right 2 and up 4, placing me here, right 2 and up 4 from the center. So if we talk about, well, I have a clear pattern happening here, the question is, what would happen if we did this infinitely? And what we hope to see is that if I kept going on infinitely, you would actually get this line shape. So in other words, to answer the question here, what would it look like if we plotted an infinite number of points? We can say that we would get a line. So to talk about this more, it's not a coincidence that we got a line and that these equations are called linear. So we saw that if we connected the points we plotted, that the basic shape of this equation, y equals mx plus b, is a line. And this is also what is called a linear graph. And again, this is no longer a coincidence. Linear literally means it looks like a line, and I have that emphasized for you down here. Linear, I can see the very first part of that word is the word line. So when I have something of this form, y equals mx plus b, we do expect to get these line-shaped graphs. So let's explore a few more of these and see if we can practice sketching these graphs. Now we'll notice that the lines are going to move, but that the basic shape of a line is always going to result. So here's our first example, and again I want to plot y equals 2x minus 4. We can look for the pattern of the line by first plugging in some points, and again we just want to emphasize this is of that equation of the form y equals mx plus b. I can imagine that if I talked about this equation, that the 2 is essentially my m value, and the negative 4 is essentially our b value. Now we'll talk about the significance of this more for now, but for now we just want to notice that we do have the m and the b values established. But let's go ahead and plug in a few points here. So if I plug in first the x value of 0, I have y equals 2 times 0 minus 4. 2 times 0 is 0, minus 4 is a negative 4. And I immediately notice that my first xy pair then on my graph should be the point 0, negative 4. So I'm going to go right and left 0, down 4, placing me here at negative 4 on the y-axis. So if we continue, I can now plug in the point 1. I have y equals 2 times 1 minus 4. 2 times 1 is 2, minus 4 is a negative 2. So my next point is right 1 for the x, down 2 for the y, or in other words, I have this point right here. Continuing, if I now look at the point 2, that's telling me to plug in y equals 2 times 2 minus 4. 2 times 2 is 4, minus 4 is 0. So our third point then on the xy axis is 2 for x, so that's right 2, 0 for y, so I'm not going up or down, and our third point falls right here on our graph. Continuing, I can plug in 3, giving me y equals 2 times 3 minus 4. 2 times 3 is 6, minus 4 is 2. And I can now see that the fourth point is the ordered pair 3, 2. 3 tells me to go right 3. 2 tells me to go up 2. And there's our fourth point. And then finally, our last point here, the point 4, this tells me to do y equals 2 times 4, which is 8, minus 4, which is 4, resulting in my fifth point from our table being the point 4, 4. So I'm going to go right and up 4. And just as promised, I can see now that I have this basic shape of a line forming. I can sketch that in. As I connect all these different points, very clearly we can see this line shape beginning to exist. Good. Now just to emphasize here, again, we'll talk about this more in future lessons, but if I return to the value 2, I notice that 2, the m value, made my graph go up faster. Right? I can see that if I trace the graph, it actually goes up quite steeply. In fact, every time I go over 1, I'm going up 2. Over 1, up 2. We'll notice that this is something called the slope. And again, we'll talk about this more in future lessons. Also notice that the b value, the negative 4, happened to highlight that I'm down 4 on this y-axis, right down here at negative 4. That's also not a coincidence. So we want to notice these patterns for future lessons. Here's another example. Now notice a little bit of a difference here. I've told you that up till now the lines are in the form y equals mx plus b. If I focus my attention on this new equation, y plus x equals 3, I notice that it's not in the y equals form. That's okay. But I notice if I would simply subtract the x to the other side of the equation, it would be in that mx plus b form. So these linear equations can come in multiple forms, but I do recognize that if I still have y and x relative to each other in an equation, that we're going to have these linear equations. Let's confirm this by plugging in and evaluating. So I'm going to plug into y plus x equals 3. I'm still evaluating x, and the first point tells me to evaluate with 0. So literally I'm going to have y plus 0 equals 3, or in other words, I'm simply going to get that y equals 3. So my first ordered pair then is x is 0, y is 3. So I'm going to move left or right 0 and up 3. So here's our first point. Second, I notice that if I plug in the point 1 for x, this is telling me to literally do y plus 1 equals 3. And just thinking logically, well, what would successfully complete this equation? Well, I know 2 plus 1 is 3, so quite simply, y must be 2. So therefore, our second point is 1, 2, or in other words, telling me to go right 1, up 2 for our second point. Our third equation, or our third point rather, is telling us to plug in x is 2, so I have y plus 2 equals 3, and since 1 plus 2 is 3, I know that the y value here must be 1. Therefore, our third point is telling me to go right 2, up 1. So my third point will be right here. Finally, the fourth point, x is 3. If I plug this in, it says y plus 3 equals 3. And since 0 plus 3 is 3, I can be pretty confident here that my fourth point is the point 3, 0. And this is telling me quite simply that I should be going right 3 for the x, up 0 for the y, or in other words, my fourth point's right here. And then finally, if I plug in the x value 4, this is telling me to do y plus 4 equal to 3. And since negative 1 plus 4 is 3, I know my y value is negative 1. Therefore, my final point is 4, negative 1, telling me to go right 4, down 1. And now if I put all these points together, just as we've seen before, I do still get this line shape, which I can sketch in. And there's that line shape that we were expecting. Now, one thing you will notice, and I want to emphasize this, we notice that this time, unlike the last two times, the line is actually shooting down instead of up. Now, what causes this? Well, again, we'll talk about this more in the future. But if I take my original equation, and I'll do this down here in blue, if I take the original equation, y plus x equals 3, I talked about earlier how this is not our mx plus b form. However, if I subtract x to the other side, or in other words, rewrite it as y equals negative x plus 3, I notice now that my equation is in that exact form, y equals mx plus b, where I notice that this x term is our m term, and notice that since the m is in fact negative here, this is actually causing the line to have what's called a negative slope, or in other words, to shoot down. Also notice that this plus 3 here is still telling us our y-intercept to literally go up 3. So again, these will be topics we talk about more in the future, but these are definitely good things to recognize as we look at these problems. So on to our last example together. Again, I'm not in this form, y plus 2x equal to 5, in our normal mx plus b form that we talked about to begin with. But it is still a linear equation, because I do still have y and x being related to each other in an equation. They're not being squared. There's not absolute values, just square root signs here. So when I plot this, I do expect to get some type of a linear equation. So let's go ahead and graph this by plotting in some points again. So if I plug in, my first equation tells me to plug in 0 for x. So y plus 2 times 0 equals 5. That literally is just going to tell me that since 2 times 0 is 0, y plus 0 is 5, so y must be equal to 5. And if I plot this now, my first point is going to be at 0, 5, or in other words, left and right 0, but up 5. My second point is x equals 1, and if we plug this in, I get y plus 2 times 1 equals 5. Since 2 times 1 is 2, and I know that 3 plus 2 is 5, I know that my y value here must simply be 3. So then my next ordered pair is 1, 3, so I'm going right 1, up 3 for my second point. The third x value I'm asked to plug in is 2, so if I do y plus 2 times 2 equals 5, 2 times 2 is 4, and I know that 1 plus 4 is 5, so my y value here must be 1. So plotting this value, my next ordered pair is the value 2, 1, telling me to go right 2, up 1. So here's our third point. Our fourth point I can plug in is the x value of 3. So that's literally y plus 2 times 3 equals 5. And I know 2 times 3 is 6, and that negative 1 plus 6 is 5, so my y value must be a negative 1. So my next value is going to be at 3, negative 1. This tells me to go right 3, down 1, so I'm plotting that point. And then the final value, at 4 for x, I'm plugging that in, getting y plus 2 times 4 is equal to 5. And since 2 times 4 is 8, and 8 plus negative 3 is 5, I know my y value must be negative 3. So this is telling me to go right 4, down 3. Here's my final point right here. And just as we've been seeing throughout this entire lesson, I continue to get this line shape, which I can sketch in. So again, I see this new line. Now, again, we noticed a couple things. It's going down like our last equation, but it's actually going down even steeper. So again, I want to explore, again, we got a line, that's great, but I want to explore why that shape happened. If I look at the equation, y plus 2x equals 5, I again notice that this is not in that mx plus b form. Right? I see that the y and the 2x are on the same side, not in that y equals mx plus b form. However, if I subtract the 2x, this gives me y equals negative 2x plus 5. And if I examine, I notice that our m value is negative and it's also 2, which makes sense because now I see that the graph is going down and it's also going down steeper at a rate of down 2 over 1. So again, I notice that this whole slope relationship is in existence. We'll talk about this more in the future. And then also notice that the b value here is 5, and that I can literally see in the graph that the line is crossing the y-axis up 5. So all these constant patterns are being recognized. But again, main key takeaways from this lesson, I want you to notice that when I have x and y related in an equation, nothing else, and if I can write them in this form y equals mx plus b, they are in fact linear, which means we can graph a line. So there are 4 on your own problems I'd like you to try. Plug in the points, get the xy pairs, and then sketch the line, and then we'll check on this again next class.